CAD. This is the diameter. So we have a semicircle up here and a semicircle also at the bottom. All right. So that means this angle here is 90 degrees. And that means this angle here will also be 90 plus 24. Well, this and this should be 180. So here has to be, I think, 56 degree.
Because it looks like an isosceles triangle because the 2 points meet in the middle.
Okay, this is an isosceles, right?
Yeah.
Good. So that means x will also be 42.
Yeah.
Good. S will be 40. So CAD is actually 42. Good. Radius, and they are the same. So here's going to be 42, 42. Correct. And next, we need to find the angle ACB. ACB, that's this angle here. Okay. So if here is 90, and here is already 42. So you add this, that's 132. And then subtract it from 180. That's 48. So ACB is 48. Did you get that?
Yes.
And lastly, looking at BCD. Okay, so the whole of this angle. Okay, so basically what you do, since you know here is 48, you need to add this to angle 56 plus 48. That's 104 degrees. Did you get that?
Yes.
Okay, so again, AOD, we need to work out AOD. AOD, this angle. And this is a straight line, so we can easily work out here. They add up to 180. So here will be 34 degrees. I'm on a straight line. And to find here, you double that by 2. So 34 times 2, that's 68. So angle S is 68 degrees. What do you get?
68.
Good. And then this one, we will work out the angle X. Again, this is pretty straightforward. Here and here are the same, alternate segments. And if here is 42, you can easily work out X in this triangle. That's 42 plus 55 plus angle X equals 180. Angle on a straight line, angle in the triangle. If you add these two, that's 97 plus X equals 180. So X definitely going to be 180 minus 97. And that's going to be 3 here. And here will be 8. Did you get 83?
Yes.
All right. Next, again, we have another AC is a tangent and BC is another tangent. And because they're tangent, they're going to be equal in length. Again, this is the radius and this is the radius. So this is also 90. And this is also 90. So you want to work out angle X. All you needed to do is to say this 90 plus this 90 plus this 4x plus this angle X. All 4 angles add up to 360 degrees because it's a quadrilateral. So this 180 plus, you add this one, that's 5x plus 360. And subtract 180 from both sides. That's going to be 180. And divided by x by 5. Now that will be 36 degrees. Is that what you got?
Yes.
You're 36 degrees. Another one. Okay, we have QRST points on the circumference, QRST, the center O. And we know PQR and PTS are both straight line. Okay. All right, this and this. So find the size of RPS. S, okay? So this angle Y. Wow. Quite interesting. So first thing first, you can actually find the reflex of the reflex angle here, the reflex angle ROT, by doing 360, take away 110. That's 250. So the reflex here is 250 degrees. And to get here on the circumference, you divide that by 2. That's 125 degrees. So here's 125. Now the reason you divide by 2 is angle of the center. Again, it's twice the angle of the circumference. And if here's 125, and again, you see this is a straight line, you can easily work out this angle here. So you do 180 minus 125. That's 55 degrees. So here's 55. Now you can see that this is a triangle now. So add 55 plus 103. 158. And then subtract that from 180. Because that's 100. Sum of angles in the triangle. So that's going to be like 22 degrees. So angle Y or RPS is 22 degrees. So for this one, they want to work out the angle, the size of the angle AOC. AOC. Wow, this angle here. Okay. AOC, they want to work out this angle here. All right. Now, this is a tangent, and this is a radius, so here's 90 degrees. Also, this is a radius, and this is a tangent, and this is also 90 degrees. So you can easily work out this angle here for this triangle, for COD, open the triangle. This plus this should be 180. So definitely this angle here will have to be 51 degrees. Yeah, 51 degrees. And yeah, so if that's 51 degrees, you can also take here also, because if this, you can also take here as 29, and also take here also as 51. So you can now see you have angle on a straight line. So you add 51 plus 51, 102, and then subtract that from 180. AOC is 78. What's your answer?
I got the same thing.
Okay. And then again, look at this one. You have a cyclic quadrilateral and a isosceles triangle and a straight line. So you want to work out angle A. Okay, so if you work out this angle here, it will be, you add this, because these two angles will be the same because they're part of this isosceles triangle. So you do 180 minus 82, which will be 98 degrees, right? And half it. So here's 49, and here's a 49. And if you look at this, this, you can see that actually a cyclic quadrilateral, So angle A will have to be 180 minus 82. That's going to also be 98. So this angle is 98. A is 98. What did you get?
I got the same thing.
Good. So A is 98 degrees. And next, you work out the value of B. Now, B will be, well, let's put here's 98, okay? So to work out this angle B will be the same thing as 49. Alternate segments. This is the same as this angle here. So B is 49 degrees. What did you get? And then write down the name of the second term using part B. For part B is
Oh no. I think
yeah.
I numbered the questions wrong because for part C I said alternate segment theorem.
Yeah, of course, to get the reason is alternate segment. Yeah, it's alternate segment. Yeah, this is this.
Yeah, I think I numbered my questions wrong. So I got the same thing. I got 98 and 49.
Okay. All right. So again, we need to work out the angle AOC. That's this angle here. And this line is parallel to this. And this is a radius. That makes a tangent. So here is 90. AOC will be 90 plus this. And then subtract it from 180 to get this. So here will be 58. So AOC is 58. Did you get that?
Yes.
Next, we need to work out angle BDC. BDC. That's this angle here. Now, again, you might think this is same segment. You might think this is alternate angles are the same, but they're not. This actually angle made at the center is twice the angle made at the circumference. So this angle, BDC, has to be divided 58 by 2. And that's going to be 29. So here's 29. What did you get?
58 and 29.
21. And for this one, QRS, that's A. Okay, so if you look at this angle here is the same as this angle here, which is 35. And so you can easily work out here. And this plus this, 35 plus 80 is 115. And then subtract it from 180. It's just about 65. So here's 65. So this angle A now, QRS, is going to be opposite angle of a cyclic quadrilateral. 180 minus 65 is 115. Did you get that?
Yeah.
Good. Next, you have to work out the angle B, which is RQS. So here's 115. Okay. Consider this as a cyclic quadrilateral, QRXP, okay, as a cyclic quadrilateral. Okay, it doesn't make sense yet. Okay, if you look at this, look at this line, it has an arrow, and this is another line, it's an arrow. So you have a Z shape here. Can you see that? So that means this angle is the same angle here, which is 35, which is a alternate angle because this arrow and this arrow are parallel. So if here's 35, you can easily work out B now. It's going to be 115 at 35, which is 150. And then it's subtracted from 180, which is 30 degrees. So here's going to be 30 degrees. What did you get?
I got the same thing.
And then you go to the next question. So you want to work at the angle OCQ. That is this angle here. Okay. All right. So we know this angle here will be double the angle at the center, or half of it, double or half of it. So here's going to be 58 divided by 2, which is 29. So here's 29. And we also know here to be 94. So here's also, then here, because you have a straight line, so it's going to be 180 minus 94, which is going to be 86. Yeah. So here's 86 degree. And we can actually find this angle here, which is 86 plus 29, which is 115. And separate from 180 because the sum of angles in triangle, which is 65. Now, if this angle here is 65, you can easily work out this angle here because it's a straight line. You do 180 minus 65, which will be 115. So angle OCQ is 115 degrees. What did you get?
I got 115 as well.
And here you want to work at the angle EFG. That's this angle marked X. Quite interestingly, angle at the center is twice the angle at the circumference. So here is going to be 96. Multiply this by 2. Good. And this is an isosceles triangle. So we can easily work out these two angles at the bottom. You do 180 minus 96, which is definitely 789, 84. And then half it by 2, which is 42. So here's 42, here's 42. And now, if you look at this angle, if we add these two angles here, these two angles at H, GHE, which is this angle here, that's going to be 42 plus 31, which is 73. So if this whole angle here is 73, let me just show you. If this whole angle here is 73, let me just put it. If this whole angle here, total angle here, is 73. You can see that this is exactly quadrilateral. So angle S will be 180 minus 73, which will be 107. So angle EFG is 107. What did you guys answer?
I got 107.
Good. And then this one, ratio. So you want to work at angle Z. The ratio of W to X is 5 to 7. W to X is 5 to 7. And you know that if you add these two angles, W plus X, if you add it up, it's going to be 180. So I think what you're going to do, you divide 180 by 5. What does that give you? No. If you add W and X, okay, they both share 180. Okay, they both share 180. So if you add the ratio, 5 plus 7, that's 12. Okay, add 5 plus 7, that's 12. And then divide 180 by, divide this 180 by 12. If you divide 180 by 12, what do you get? Can you use your calculator?
Yeah, I'm doing it.
180 by 12?
15.
15. Then 15, right? That means the ratio will be 5 plus of 15, and 7 lots of 15. That will be here will be 75. So x is 75 degrees. No, w is 75. And x will be 7 times 15. That's 105. Okay. Okay. So for this question, what was the length of OQ? OQ, and this is 90. Here is 30. Here also has to be 30 also, or the same length. So OQ, you can use particular theorem. Use particular theorem. That's going to be 34 squared is equals to 30 squared plus s squared. And that's going to be actually be s squared is equals to 34 squared minus 30 squared. Now, if you bring space here, so s squared is going to be, if you do 30 square, if you do 34 squared minus 30 squared, what do you get?
256.
256. And then to x, you're going to square root of 256. What does that give you?
16.
16, right? So we know x, this QOQ is going to be 16 centimeter. What do you get as your answer?
I got 16 centimeters.
Good. And next is to look at the circumference of the circle to 1 decimal place. Okay, the circumference of the circle is actually calculated using the formula 2 pi r. All right, that's circumference.
Yes.
So it's going to be 2 times pi times the radius, which is 16, 32 pi. And if you punch your calculator, the 2 pi, what does that give you?
Pardon, what did you say I should do?
If you multiply 32 times pi, what do you get?
Pi. To how many decimal places? To 1.
Yeah.
100.5.
100.5.
Yeah.
So that's the answer to 1 decimal place. Centimeter. What did you get?
I got the same thing.
Okay. Next. Number 27. They want you to work out ABD. That's this angle here. Well, if you have to do this one, there are quite a number of ways. Look at this triangle here. They are the same length. So here is 2x. So that means here also is going to be 2x. The reason again, the first is base angle of an isosceles triangle. Next, this is alternate segment to this. And now we can now add this to form 180 angle on a straight line. So you have 2x plus 2x plus x plus 15. We add up the 3 angles, you get 180. So we add this, that's 5x plus 15 equals 180. So subtract 15 on both sides. That's 5x is going to be 165. So x would now have to be 165 divided by 5. That gives you what? 33. What does it give you?
165 divided by 5.
Yeah.
33.
So angle ABD is actually 30. Okay, if x is 30, no, okay. If x is 33, then this angle, the whole angle, is going to be 2x, which is going to be 33 times 2. which is 66 degrees. What did you get?
I got the same thing.
Good. So ABD is 66 degree. And then this one, all right, from the length and AOB, we want to work at the angle AOB. Yeah, this angle. Okay. All right. I think so this one you're gonna do something like you're gonna use trigonometry because this is 90 degrees, radius and tangent. So this is the hypotenuse and this is the adjacent. So you're gonna use SOHCAHTOA, which is car. You're gonna use this one, cosine. This is cos x. The adjacent is 3, and the hypotenuse is 14. So S is going to be the cos inverse of 3 over 14. And if you do that with your calculator, the cos inverse of 3 divided by 14, you get 77.6. 77.6 degrees. What did you guys answer?
I got 77.6.
Good, that's the correct answer. And then the last question. We want to prove that AOB, there's this angle here, is 4x. To prove that this angle is 4x, this angle here is 4x, you can consider that this is a radius and it's a tangent. So this whole angle here is going to be 90. So what I think we can do is to say 90 minus 2x. So this angle here is going to, this angle here is 90 minus 2x. Again, because this is a radius and this is a radius and they have the same length. So here also will be 90 minus 2x. So to work out this angle here, you do 90 minus 2x, add 90 minus 2x, plus this angle here. Okay, let me call the angle B. You can call it anything you want to call it. That's going to be equal to 180. So if you do 90 plus 90, that's 180. This minus this is minus 4x, and this is B, and that's 180. Now, if you subtract 180 from both sides, you're going to have 4x plus B is equal to 0. So B now will be add minus 4x on both sides. That's 4x. So that's how we know that angle AOB is 4x.